So this is an example of how the sender computes the CRC and how the receiver uses that CRC to check if there are errors or not. So the first thing we need is the generator, G. So G is usually given in the question. So G can be either given in the binary format, or it can, as we discussed in the lecture, it's a polynomial, an algebraic polynomial. So it might also be given as an algebraic in the algebraic polynomial format. So let's take the algebraic polynomial format and convert it into a binary format. So let's assume that we have this x cube plus x square plus 1. This is the generator given. Now we have to convert this into the binary format. And excuse my writing as always, right? So what should we do? First we write this algebraic expression in its, what we can just call it in the standard format. It's just a term I'm using, it's not any standard term. So but when I write it, you'll get to know what I'm saying. So what it means is that I write it as 1x cube plus, what is the next one, 1x square plus, okay, so x1 is missing in this algebraic equation, so that means it's 0 x raised to the power 1 plus, and what is this 1 is 1 x to the power 0, right? I hope this x raised to the power 0, I hope you understand this, right? So now you see in this standard form, which I'm calling the standard form, we have the algebraic equation in this. So the coefficient, which is this are actually the bits of the generator, and this power is simply the location of those bits. So what will be the generator in this binary format? It will be simply the coefficients location wise, which is being given by the exponent or the power. So the generator in binary format will be 1 1 0 1. Clear? So this is the generator. So in the question, in the exam or quiz or the assignment, the generator might be given in this binary format, or it might be given in this algebraic polynomial format. So if it comes into the algebraic polynomial format, please don't get confused. I have just shown you the way how to convert it into the binary format. Now you have the binary format generator. How many number of bits in the generator? 1 2 3 4 bits. So R, if the number of bits is equal to 4 bits, right? Okay, now let's assume that the data to be sent is data to be sent by the receiver. Data to be sent by the receiver is okay, let's assume it is 1 0 1 1 0 1 1. So this is the data to be sent. So now what will the sender do at its end? The first thing the sender will do is that it will append some zeros here. Append zeros, or append how many zeros? N zeros, n number of zeros at the end of the data. So how do we calculate the value of n? So where n is equal to r minus 1, that is n should be 1 less than the number of bits in the generator. So n should be, what was r? R was 4 bits. So 4 minus 1 is equal to 3. So 3 zeros to be appended. So what is our data? Our data was, let's write it again, 1 0 1 1 0 1 1. So this is the data, the original data bits. Original data bits, and we append what? N zeros, and n was 3, so we append 3 zeros, 1 2 3. Okay, so now we get this process is being done at the sender end, right, before transmitting the data. So this is how the CRC is computed. So it's not finished yet, we are continuing. So now this bit string becomes this complete. Okay, so let me grab a new page because this page is finished. Okay, so now in the next step, the sender continued. What does the sender do? It actually now performs a binary division. Okay, so now let's perform the operations at the sender. So what was our modified data string with the n number of appended zeros? It was 1 0 1 1 0 1 1 0 0 0, right? And we have to now, the sender, what does the sender do? It divides this modified or the appended data string with the generator. I'll just put this sign here so you know this is the end. So I'll put this for the division so you don't confuse it with the 1. So I'm just using this sign so you don't confuse it with the 1. So what was our generator which we computed from the algebraic polynomial? 1 1 0 1. Okay, so I guess you guys all know exclusive OR. So what is 1 exclusive OR 1? It is 0. What is 0 exclusive OR 0? It is 0. What is 1 exclusive OR 0? It is 1. What is 0 XOR 1? It is 1. So the simple rule of thumb is what? I'm sure you already know this, that whenever the bits are the same, the answer is 0. 1 1 1 exclusive OR 1 is 0. 0 exclusive OR is 0 is 0. And when the bits are different, then the answer is 1. So 1 exclusive OR 0 and 0 exclusive OR 1 is 1. So what is 1 XOR 0 XOR 1? So 1 exclusive OR 0 is 1. 1 exclusive OR 1 is 0. So I hope you get it. Okay, so now let's go back to the binary division, the modulo 2 arithmetic division. So we start with the leading bit, which is 1 in the data, which is this one. So we perform an exclusive OR with the generator. 1 1 0 1 XOR. Okay, so 1 1 exclusive OR 1 1 is 0. 1 0 is 1. 0 1 is 1. 1 1 is 0. And copy the remaining string here. 0 1 1 0 0 0. Now we start again with the leading, right? Leading 1, the most significant bit, which is 1. So again perform an exclusive OR 1 1 0 1 XOR. So 0 1 is 1, 0 0 is 0, 1 1 is 0, 1 1 is 0, and copy this string, the remaining string, 1 1 0 0 0, right? Now again start with the leading 1, so 1 1 0 1 XOR. So 0 1 is 1 1 0 is 1 1 1 is 0 1 1 is 0, and copy the remaining 0 0. Okay, so now again start with the leading 1, so it is 1 1 0 1. Now there's no remaining from the above string, so all are being exclusive ORed. 0 1 is 1, 0 0 is 0, 1 1 is 0, 1 1 is 0. So now we have to stop the division. Why? When the number of bits including the leading 0 in the remainder become less than the number of generator bits, so we have to stop the division. So now the number of bits is after the lead, including the leading 1 and after it is 1 in the remainder, and the number of bits for the generator are 1 2 3 4. So 1 bit is less than 4 bits, so now this we have to stop. Okay, now what the sender will do is that the sender will, how many zeros did we append? N. What was N? It was R minus 1, which was the number of bits in the generator minus 1. So N was 3. So it will take the 3 from the remainder. It will take these 3 bits, and it will now again replace the zeros which we appended in the data string, and it will form a new data string 1 0 1 1 0 1 1. And what are the 3 instead of the 3 zeros? What will it be now? 0 0 1. So now this is the data string which will be transmitted by the sender. Okay, clear? So this is how the CRC operation is performed at the sender side. Okay, so if the generator number of bits in the generator string, that is the value of n, would have been 5, then we would have taken 4 bits here, right? So it is n minus 1, and we would have appended 4 zeros here, right? N minus 1. Clear? So now let's see what happens at the receiver. Let me grab another page. Now let's assume that the receiver receives this string error free without any bit error. So what will it receive? It will receive 1 0 1 1 0 1 1 0 0 1, right? This was transmitted by the sender, which is the CRC'd data string, including the data plus the CRC, right? So this was actually the what you can call the CRC. Okay, so now the receiver will again perform that binary division with the generator. The generator is known to both the sender and the receiver. They pre-agree this, right? So it will again perform this binary division, and if the remainder comes 0, then that means that this is a valid string and there was no bit error which happened. So let's divide 1 1 0 1. So exclusive OR start with the leading 1 1 1 0 1. Okay, 1 1 is 0, 1 0 is 1, 0 1 is 1, 1 1 is 0, and copy the remaining string 0 1 1 0 0 1. So again start with the leading 1, so 1 1 0 1 XOR. Zero 1 is 1, 0 0 is 0, 1 1 is 0, 1 1 is 0, and copy the remaining 1 1 0 0 1. So again start with the leading 1 1 1 0 1. XOR 0 1 is 1 1 0 is 1 1 1 is 0 1 1 is 0, and bring down the carry down the remaining. Now again start with the leading 1 1 1 0 1, and there is no further to carry down. Now we are performing the XOR with all the bits. So again XOR it. 1 1 is 1 exclusive OR 1 is 0 0 0 is 0 1 1 is 0 1 1 is 0, and now the remainder is 0, and there is no 1 in the remainder, so we can stop now the division as well. So this means that the remainder is 0. This means that this string which was received is valid, right? Got it? So this was done, this operation was done at the receiver. So this is how the CRC is performed. Now let's assume that there was an error in one bit, and during the transmission, a router or the transmission link or whatever, wherever, one bit was flipped. So let's assume that the third bit was flipped from, so the original string was what? 1 0 1 1 0 1 1, original transmitted string 0 0 1. Now let's assume that the third bit is flipped from 1 to 0, meaning a bit error occurred. So what will happen? We have the string now at the receiver end. Now the string would become 1 0, the third bit is flipped to a 0, so the meaning is same, 1 0 1 1 0 0 1. So now let's again divide it, 1 1 0 1, exclusive OR it, 1 1 0 1, XOR 1 1 is 0 0 0 is 0 0 1 is 1 1 1 is 0, and copy the remaining, carry down the remaining 0 1 1 0 0 1. Okay, so now start with the leading 1 1 1 0 1, XOR 0 1 is 1 0 1 0, and carry down the remaining 1 1 0 0 1. Now start with again the leading 1 1 1 0 1. I hope I have enough space at the bottom of the page. So 1 1 is 0 1 0 is 1 0 1 is 1 1 1 is 0, and carry down the remaining 1 0 0 1. So again start with the leading 1 1 1 0 1, XOR. So 1 1 is 0 0 0 is 0 1 1 is 0 1 1 is 0, and carry down the remaining 0 0 1. Okay, now you see that the number of bits including the leading one, and after it the number of bits is, there's no other bit, so the number of bits is only one, which is less than the generator, so we have to stop the division. So what is the remainder which we take? The 3 bits, so it is 0 0 1. Now is this a 0? No, this is not a 0. So that means the receiver will realize that a bit error occurred, and it has to discard this data. It cannot trust this data, right? Because the remainder is not 0. So this was the CRC. I hope now the CRC process is clear to you.